Okay, make sure your cell phones are off. They can be on your desk, but make sure they're completely off. It's totally fine if you haven't plugged into the wall and you need a charge. All right, we had a quiz yesterday. What's up, Ray? They're graded, yes. And you did well, sir. I feel the class as a whole did really well. Now, some of you didn't get completely done, which is fine. If you needed extra time, come see me. Yours is graded already, but what I'll do is when you get it, come see me. I'll switch up what the grade is in there. So I'm just trying to light a fire because I found that last semester. Some students that needed extra time, the grade wasn't going in for a couple weeks because you're just sitting there. So now it's a lower grade than you probably should earn, but it will change as soon as you take the opportunity to get a little bit further. We're on our adventure of systems of equations, and the systems of equations that we are solving are linear. Okay? Eyes up here, please. Notes out if you're taking notes. If not, let's figure this out. So, waiting. This is the next little portion. We are still using our old notebook, but starting next week, no, the week after. So next week we have no school Monday, still old, and then the following Monday we have a review, and the following Tuesday, which is the 26th, we have a review, and then we have the test on a Wednesday. Now, some of you had emailed you did fine on the quiz, but you're like, it's just, I think I could do better. And I agree. So my deal for you is, if you show me on a test that you feel good about the material and did better, I can keep your score in for the quiz, but I'll put an exempt in there, meaning you'll see the score, but it'll be exempt, meaning it's not counting towards your grade, which means technically you could bring your score up pretty quickly if you prove on the test you're able to do the stuff that was on this quiz, which you will definitely see on the test. The only difference between what we're going to start on now is we're going to create more and more word problems. We've already started with some of the word problems, but we're creating a system of equations using word problems to decipher it. And word problems, they're not everyone's favorite. I get it. So how I want to go through the next couple of days is I'm going to, if you have your notebook, open it up. If you need the next couple pages, I have a few copies that I have made, so you can come on up and I'll get you this. Or if just raise your hand. Ray, you need one? You got the new one or the old one? New one. This is from the old one. Pass that back. You want to see it? This is just if you need it. If you didn't have the book still, it's the next couple pages. Yeah. Oh, alright, so I feel the best way to run through these is let's get to the page that we're on, because I want to go through the word problems themselves to make sure we're good. Okay? So right now I'm on page 136. So get to 136 and I'll be right back. I want to get my note cards real quick. What do I need to do? Damn, she didn't do that. Yeah, you owe me money. You won't give me any. You said what? You owe me money. Bitch, I made a guy yesterday, and then you want me to pay you right now? You owe me dollars. You should have money right there. Alright. I was recording the whole time while I was gone, so if I say anything bad, it's not recording. You're in trouble. Okay. Bo, yours is the one on top, so you're going to go to the back. Cool? All right. Everyone find the appropriate page. George, do you have your book? Or? Page 136 we're on. If you have needed the packet, you should have it. Let's take a look. So what I want to do is I'm going to work through some of the problems, and then the remainder of those problems would be what the assignment would be to be checked off. Does that make sense? Yeah. So that way you have pretty much a portion of a guide in hand. Okay? So the directions on page 136, which is worksheet number 7, says solve each system of equations. Be sure to label the 2 variables and write the 2 equations, then solve them for your solution. So we're solving a system of linear equations. A linear equation will have 2 different letters. Now we had been using x and y, but we don't have to just use x or y. And the reason it stays as a linear equation is that our 2 variables are not multiplied together, so we don't have x times y or m times n or o times q or something like that. They're not squared, they're not square rooted, they're not raised to the 3rd power, they're only to the 1st power. So they're all set up as some sort of linear equation, whether it's set up in a form of y equals mx plus b, where y and x are your variables, or ax plus by is equal to c, which is a standard form, where again your x and your y are your variables. Or it could just be set up where we happen to know one of the variables and we just have to substitute it into the other. Okay? With these, we more than likely will not use graphing to solve. Now, there will be some graphing exercises that will take place because you can use graphing to show how these work. Well, if you're labeling, M and T for money and time or something like that, you probably don't want to go and graph that, figuring that the x-axis might be the m-axis and the y-axis might be the t-axis and things like that, because then you get into the whole conversation of, well, how do I know that's the x-axis versus the y-axis? And so we're not going to even worry about it. Okay, so Sophia, I'm coming to you first. Ready? Okay, so it says last year, you, Sophia, mowed lawns or shoveled snow for 10 households. That was nice of you. Oh, wait a minute. You charge some money, these people. Still with me on this, Sophia? You charge $200 a season to mow the lawn for each of these places. You charge $180 a season to shovel snow. Okay? So, on a non-snowy year, you're coming out on top. On the year where we're getting feet, you might not have wanted that, but it's going to work out. If you earned $1,880 last year, how many households did you mow the lawn for, and how many did you shovel for? Use the system of equations to solve this. So again, we need to set this up. Sophia, do you understand the scenario that we're going with? Your mowing and shoveling service, whether it's snow. Okay. You did it already? It's done? You got it all done? Really? Oh my gosh. So, problem number 1 on this page says, so, Sophia, what did you label your variables? Did you label them X and Y, or did you M and S? Okay. Let's see. Oh, he's here. Oh. But I wanted it. All right. Sophia, say it one more time. You used M and what? S. M and S. So that's mowing and to shovel. Yeah? And I'm making that S kind of look exaggerated because sometimes S's in math get confused as a 5. Yeah? So that's why I'm going to exaggerate it a little bit. Not connected. See what happens when I exaggerate? And then it becomes an 8. All right, so how many households did you help? 10. So these households, there's 10 homes that you took care of. So you mowed and shoveled 10 households. Yes? Seem good? Sophia, you're off the hook. Thanks for playing along. George, coming to you, bud. Why? Because you were next in the cards. Oh, hi. All right, so do you charge a different rate for the mowing season versus the snowing season or shoveling? Take a look at what the problem says. How much? How much do I charge to mow the lawns? Yeah, this is going to cost $200. And what about the shoveling? How much is that going to cost us each season? How are we going to charge? $180. Cool? All right. So between my mowing and my shoveling, I was able to make how much money last year, George? Is that right? So by you charging, these 10 households, George, by you charging $200 for the mowing season and $180 for the shoveling season, that's how much money you were able to make. Make sense? I like it. All right, so, George, I'm definitely set with this equation right here. But I want to make another equation that's equal to 1880 using the shoveling and the mowing still. And they're still going to be added together. But I want to put the value of the mowing season and the value of the shoveling season in there. So how much do I charge for a mowing season per yard? 200. Did you get that? How much did I charge for the shoveling season? 180. So some combination of these 10 homes, is going to tell us how many we mowed, how many we shoveled. Okay? So, it says if you earned $18.80 last year, how many households did you mow the lawn for, and how many did you shovel for? Of these 10 households, I did not necessarily mow and shovel the same amount of yards and sidewalks. So someone might have had a big old yard saying, yeah, go ahead and shovel it, but they had that heated driveway, and they ain't worried about it. Okay? So my system of equations, my system of linear equations is m plus s equals 10. Because that was the total of how many I did. But then I did 200m plus 180s is equal to 1,880, which is what I made as far as my money. Thanks, George. Gage, those are set up. They're linear. Even though I'm using m and s versus x and y, they are linear. They're linear because m is not raised to a power or square rooted or anything like that or divided. And same with s. And they are not being multiplied together. So I have m plus s, and then I have 200m plus 180s. So do you feel these would be good to graph? No, probably not good to graph. I mean, though the cover method would work, we don't need to get into the worry of, I have this. Hang on, only one person out to the restroom at a time. Thank you. Okay? So I have these two. Just like that. Okay? So Gage, I think the elimination method is going to work nicely. And the reason I'm going to say that, and I feel that, is the m's are like in a column with each other as well as the s's, and then the constants are its own thing. What letter do you want to get rid of? Your choice, M or S. M, I like it. If we get rid of M, if we're choosing to get rid of M, what do you think I should multiply the entire top equation by that when I add it to the other equation, it's gone? You're real close. If it was 200 right now, negative 200, does that make sense? So if I multiply this whole thing by negative 200, okay? So guys and girls, if you take a quick shot at, just try and set that up, see what happens when they eliminate. I'll be right back. I just want to grab a box of tissues. What do you need? Oh, the registry.
Like the no, actually, it must be a. I think I have a feeling I know where this is. By the ski. It's outside.
You pass it every single day you walk in. Register. Yeah.
That better be quick. I have to learn all the cards. Yeah. And I'll have one off, so I can't eat again. So because of this.
Oh, you went for 4?
Yeah. Because I only have one off. And I have to go grab myself.
Okay. I went through the cameras. Cool. All right, Gage, you're off the hook. Hey, Reese.
Yes.
Let's do this math right here real quick. What is that going to result on that top equation?
Is that going to be negative 200m?
Uh-huh.
Negative 200s.
There we go.
And it's going to be negative something.
2,000.
Okay.
Reese, does this one get changed at all?
No, it stays the same.
Okay. That's a plus, right?
Yeah. Now I'm going to take a wild guess that we're going to have to take off the negative 200m and positive 200.
So these cancel?
Yes.
I like it. Everyone following?
Yes.
Is that good? What's there? What more do we do with the problem? I have negative 200s adding, Ray, I'm adding negative 200s and 180s together. Is my answer for the s's right now going to be positive or negative? They're going to be negative, and it's going to be negative what? Negative what? Negative 20s. Very good. Now, here's a quick question. I'm getting a negative 20 right there. Would it make sense that I shoveled negative 20 lawns? No, so I bet you something's going to happen here where they're going to flip-flop. Agree? Okay, so, Ray, negative 2,000 and 1880 combined together to give me also a negative answer. What do you think the negative answer would be? How much? Negative 120. I like it. Now I'm going to divide both sides, Ben, by what in order to get S by itself? I'm going to divide both sides by negative 20. And by me doing this, the negatives are gone. So I get S is equal to negative over negative is positive. 20 goes into 120 how many times? 6. So what does S represent? It does represent 6, but what does S represent in the context of this problem? Household shovel. Good. But we're not done yet, right? Now, hey, quick question. Andrew, not here, Andrew. Angelo.
Oh, yeah.
Angelo, how many total houses did I mow or shovel? Did we know from the beginning?
You mowed 10 households.
So I mowed and shoveled a total of 10. Okay? But I just found that I shoveled 6 of them. So how many must I have mowed?
4. Gage took the words out of my mouth.
I love it. I saw him use reach. It was great. All right. So if I go back to this equation right here, pretty simple equation. M plus S is equal to 10. And I know my S happens to be 6. that means that my mowing season accounted for 4 of my neighbors. My shoveling season accounted for 6 of the neighbors. Do we know if they're the same houses or not? No. Does that really matter in the context of the problem? No, we're just trying to individualize the problem that we're doing. Okay. Hey, can we move to yeah, we're done. That's it. That's all it is. So this is a logical progression of events in order to solve the problem is all we're doing. So it's just like a puzzle.
Actually not that hard.
No, but but you know what really dials people away? Is it's a word problem. People don't like to read all that much. Now I know y'all, you like to read, the texts that come your way, but then the pictures are even more fun to look at, right? You're like, dude, look at that. Look what happened to John. And John's like, woo, flying off the, off a skateboard or something. I don't know. All right, hey, can I go to number 4? Can I go to number 4? It's on page 137. Page number 4. Okay. Pictures are fun. I get you. All right. So now we're talking about the perimeter of a rectangle. Okay. So this is problem number 4, and we're talking about the perimeter of a rectangle. Now, guys and girls, I'm dealing with a problem that is talking about a rectangle. Can we all visualize what a rectangle looks like? Yeah, some of you make the skinny on the bottom and the tall, upward. Some of you do it the other way, some of you draw it diagonal. I don't care how you draw it. Just draw a rectangle. Well, a triangle wouldn't be the legit way on this, but if you wanted to subdivide it like this with a diagonal, I guess it could be 2 triangles put together. But I kind of like it. So, do you feel okay about a rectangle? Why am I putting a rectangle up there? Yeah, it says it's a rectangle. And because we went through some sort of formal education before we got here, and we learned about a rectangle, we learned that usually the length is the long side, and the width is the skinny side. Now, when you get to geometry next year, you're going to realize that it doesn't matter if the length is the longest and the width is the shortest, but because elementary school, they're like, length is long. And so, that was their phonics for you guys to know that. Okay, so I'm just drawing myself a rectangle that I know. And when I think about a rectangle, without even going any further on this problem, I know that the perimeter equation is 2 times the length plus 2 times the width. And I also know that the area is length times width. Now, I might not need to know both those equations right off, but I know those 2 equations feed into a rectangle. Okay? That's the highway to heaven. Stairway to heaven.
There's a stairway to heaven and a highway to hell. There's a slight difference. Oh
Ah.
gosh.
Yes. And ACDC will be here in concert on a Monday in a few weeks.
I'm going to see him.
Yeah, baby. All right. So, hang on. So, problem number 4. I put up there just some information. I knew I was using the rectangle, and I put the 2 equations that deal with rectangles up there. So, let's read the problem and see if we can eliminate a few things. It says the perimeter of a rectangle is 42 meters. It is 4 meters longer than it is wide. What are the dimensions? So I knew I had 2 rectangle equations up there. One dealt with area, one dealt with perimeter. What am I dealing with the context of this problem right now? Second word. Perimeter. So I don't need to worry about this. That was just extra information. I'm just going to strike through it because I don't need an extra equation up the board going, now what am I going to use that for? Okay? So the perimeter of a rectangle, they tell us the perimeter is equal to 42 meters. Okay? And just labeling, that's all we're doing. Now we have a relationship between the length and the width. The length and the width. It says it is 4 meters longer than it is wide. It is 4 meters longer than it is wide. It is 4 meters longer than it is wide.
How many meters longer than this?
Quattro. That's Spanglish. Okay? So, with that known, let's see. I might be able to, let's see. I know that I have a relationship that the length happens to be 4 plus this. And I knew that P is equal to 42, so I know if I plug that into that, I'm going to get this. So that's just the perimeter equation. But what operation could I use? What operation could I use right now that's going to get us only one letter? It wasn't elimination, it was the other one, not graphing. What should I do with 4 plus W? It's substitution. Where should this 4 plus W go? It should go into L right here. And if I plug that in, that's going to take us down to just the W. That's going to take us down just to the W. So I have 42 is equal to 2, I'm going to put parentheses here, plus 2W. Mac, what letter was right here just now?
L.
L. What am I going to put in place of that L? 4 plus W. Okay? So, Mac, if I distribute over the parentheses, I go here and here. So I get 42. 8 plus 2W. And what about this? Plus 2W. I like it. Okay. Good job, Mac. Celine, what should I do with those 2W? Combine them. They're on the same side. I'm going to combine those. So that's going to give me 42 is equal to 8 plus... Hey! Good to see you!
Is Christian here?
Yeah.
Can I see you for a second? Thank you.
Yeah, but
What are we doing?
we are doing word problems. So we have developed story problems.
Equations.
And look at this. I'll even send you the video link it today. It's right here. It'll be on YouTube here in a little bit.
Appreciate that.
Thanks, bud. Celine, did you tell me what 2W was?
Or W?
Okay. Garvey?
Yeah.
Where should I go?
Do a little subtracting.
Subtract. Where would you like to subtract?
From itself from 42.
I like it. So that's going to give me 30. Help me out. 34? Is that right?
Yeah.
Equals 4W. So let's get W is equal to 34 over 4 because I divided. 34 over 4 is 17 over 2. Do you agree?
We did something.
What
I
do
feel
you,
like we had to.
did we do something wrong?
I feel like we.
Hang on. You know what? You know what I'm going to do?
Feels like.
I know I can make this a decimal. What's 17 over 2 as a decimal? What's 17 over 2 as a decimal? It is 8.5. That's exactly right. 8.5. 8.5. 17 over 2 is 8.5, isn't it? Yeah. Okay. Okay, so I've now found that W is equal to 8.5. What does my length have to be equal to if W is 8.5? 12. Giddy up. 12.5. 4 plus 8.5 is 12.5. And these were in meters. Now, Ben said, I think we kind of made an error someplace. We might have. I don't know. You might be right.
That can work because it's
It is length and width. Is it okay that I have a length that doesn't come out to a whole number? Okay. I think what I can do is, being I know that 42 is equal to 2 times the length and 2 times the width, that means that if the length is 12.5, if I double 12.5, this becomes 25. If I double 2W, W we found to be 8.5. If I double 8.5, I get 17. And if I add 17 and 25 together, I do get 42. We have our answer. So we have a length of 12.5 meters, and we have a width of 8.5 meters. Right?
Yeah.
I like it. So, sometimes a story problem.
That's totally.
Like the dunce hat and put a spoon in the corner so
All right, ladies and gentlemen, Can we do one more? If we do one more, that leaves you 2 problems for homework versus 3. And 2 is always better than 3 as far as homework goes. But 2's not better than 3 when you're talking about pieces of pizza, right? I always want 3 slices. Ready, Angelo?
Yeah.
Here we go. Brenna, coming to you. Not that you did anything wrong, just you were next up on the, well, you know, love you for it regardless. All right. Problem number 5 talks about a waitress. A waitress. A waitress has a total of 35 quarters and dimes in her pocket. So, waitress, you can follow me on this adventure. Waitress reaches in to her pocket or into her apron pocket or wherever and pulls out the change and puts it down and says, "Oh, look! They're quarters and dimes. And look, there's 35 of them." Okay? And again, we don't have the Chuck E. Cheese tokens in there, and we don't have the random other coins. It's just this waitress had noticed by pulling something out of her pocket as far as the coins go, there were 35 of them total, right? And they happen to all be quarters and dimes. Okay. So I have quarters, I have dimes. I think Q and D would work well. You all right?
Yeah.
What happens in stirrups class stays in stirrups class. Oh wait, it's recorded to YouTube now. All right, quarters and dimes, Q and D. I like it. Okay. Hey, Brenna, how many total coins did I happen to have? I happen to have 35. So I have my quarters and dimes that I just put down on the table. There happen to be 35 total coins, and they all consisted of quarters and dimes. Yay or nay? It seems like a plausible thing that we could go with. You know, could you have 35 coins in your pocket that all happen to be quarters and dimes? Sure. Hey, you want to know what I heard the other day? Think about this. Oh, I thought this was kind of unique. You know that Powerball, how 3 people supposedly won the jackpot? And I'm not worried about the winnings or anything like that. I saw some really bad math, though, with that. You know, the $1.3 billion, and they said, that means that everyone gets $1.3 million in the United States if they just gave that out. No, or $4.3 million if they just gave it out. No, if you take 1.2 billion and divide it by 300 million, which is the rough estimate of the United States population, you come out to $4.33. So every man, woman, and child of the United States, if the equivalent was 300 million, would have gotten $4.33 if they divided that jackpot up. So it did not necessarily end poverty, like some websites were posting. Dude, we can end poverty now. Every puppy might be wanted. You know, things like that.
Puppies.
And then the other thing that I saw was the probability. Here, think about this one. The probability of you flipping a coin and getting heads every time, 28 times in a row, was close to the same probability as you matching up the numbers on the Powerball. Now y'all are going, dude, I know I can flip a coin 28 times and get all heads. I got you. But that's just what they said. Because you have a 1/2 probability, and you take away the chance that the coin, when it falls on the floor, falls on its end. And some people are like, no, you have to account for that. Because, you know, when I'm flipping a coin, it hits the ground. It's one time it hit like that. No, it didn't. My Uncle Carl, I know your Uncle Carl. I don't really. Casey, you're up next on the cards. Is that okay? I'm sorry, I was off task. All right, so this waitress, 35 coins total, which happen to be all quarters and dimes by just visual inspection. How much money does this person have of these quarters and dimes? $6.50. So, if I were to have counted up all the quarters, and if I had counted up all the dimes, it comes to an amount of $6.50. And there's only one combination of quarters and dimes where you have a certain amount of quarters and a certain amount of dimes. That is going to make $6.50. Okay, a quarter is worth how much, Casey? 25 cents. So that's the same thing as 0.25. Still with me? And a dime, Casey, is worth 10 cents, which is 0.10.
Well, it depends on the age of the time.
Oh, we're going to say what the bank, what the bank's going to give you, not the money seller.
I mean, if you sell a dime from really old.
I understand, but if you go to the grocery store, you could have an all silver dime, and they're not going to give you the 17.5 cents that dime is actually worth as the weight of silver. Yeah, because you know I have arbitrary values like that off the top of my head. Yeah.
I actually already got it.
You got it?
I already did.
All right, let's double check it. Hey, so Karen, I don't like decimals all that much. So I want to get rid of these decimals. So technically, I'm going to multiply this whole thing. In order to move a decimal, if I multiply by 10, it moves the decimal one place to the right. So what would I have to multiply to get the decimal to move 2 places to the right? Karen? If 10 moves it one place, what number would multiply to move it twice? 100. You're absolutely right. I thought Ray was going to mess with you and say 16. That's 16! Where did that come from? All right. So if I multiply here, here, and here, that's going to give me 25Q plus 10D is equal to 650. So all I did is I got rid of my decimal. I'm not really solving the problem at this point, but I also know that Q plus D, I know that, Q plus D is equal to 35. I know that Q plus D is equal to 35. Okay? Now, it is set up in a particular way that I think the elimination method would work. Gabe, what do you think here? I have 25Q plus 10D equals 650, and then I have Q plus D, so it's 1Q plus 1D equals 35. You still with me? I think elimination is going to work well. Would you like to get rid of the Q's or the D's? Q? So what am I going to multiply the bottom equation by?
Is that going?
Yes. Negative 25. You're absolutely right, but I'm curious. Why did you select negative 25 and not just 25? Perfect. I like it. So you have to have an opposite value. So, and some of you are looking at this and going, why didn't he just multiply by negative 10? Well, because his brain saw this first. And that's cool. God bless you. Distribute, distribute, distribute. Okay, so that's going to give me negative 25Q minus 25D equals negative. Hey, can someone with a calculator go 25 times 35? I just don't know how you can do it in my head real quick. Sorry. 875, thank you. And it's negative. Okay, and so then I'm just going to bring this one along. So I have 25Q. And I have 10D. And that's equal to 650. Now, something interesting is going to happen here. I know that's gone. Tristan, 10D and negative 25D combined together gives me what?
Negative, I can't do that.
Your negative is totally right. I love it.
Negative 15.
Negative 15D. I love it. Now,
Yeah.
Tristan, let me ask you this. Is it going to make sense right now that we're going to get a negative dime amount?
Well, it's not gonna make sense.
It's not going to make sense. Not as the sense as penny sense, but logical sense, right? So it might happen that we have a negative on the other side, which means I'll divide by two negatives, which will give us a positive. All right, somebody with a calculator, 675 minus 875, help me out. Negative 225. And it looks like here, Mackenzie, what am I going to divide both sides by to get that D all by itself? Negative 15, very good. So you carry that negative along. The nice thing is I'm dividing a negative by a negative, so those cancel out. Negative over negative is positive. 225 over 15, I believe, is 15. Hey, hang on. So, Megan, I had how many coins that I pulled out of my pocket initially? 35 of them. I just found that I happen to have 15 of them being dimes. So if I knew that 15 of them were dimes, if I plug in right here, I'm going to get Q plus D, which is 15, is equal to 35. So how many quarters would you feel we would have? I have 20 of them. So I saw an interesting thing on the quiz. Our bonus question dealt with coins, and I saw that somebody had gone through and they figured out what 1 dime plus 1 quarter, and then 2 dimes plus, they were trying to figure out the combination that worked. Is that a right or wrong way of doing it?
Right.
It's totally right.
5 minutes on one process.
But you know what? Some people might say, oh my gosh, you did it that way. Why'd you do it that way? And you know why they did it that way? It's because that person's mind thought that way to go to first.
Oh.
Is that wrong?
No.
No. That's because they have that beautiful mind just like your beautiful mind, and your mind is not wired 100% the same way as their mind, and that's okay. But what's going to happen on that type of problem is that I said you had 386,241 coins. That's going to be kind of hard to start doing all the combinations of coins in that way, right?
Yes.
But that's basically what we're going with. So, ladies and gentlemen, I really like this stuff today. So we did which problems did we do? We did the 2, 4, and 5? 2, 4, and 5? Yes. So that leaves us problem number 1 and problem number 3 on this worksheet that I'd like to check off on Tuesday because we don't have school on Monday. We okay with that?
Yeah.
Yeah.
So, guys and girls, can I get through these word problems with you all? I'm trying to paint it as a picture. I want you to realize that a word problem is something that we should not fear when we come across it. It's just trying to tell you a story. It's not the best story ever. It's not reading your favorite book ever. But it's a story in itself.
So we can throw these books away?
Not yet.